Limits of function. What is limit of function? The limits of a function is a fundamental concept in calculus and analysis concerning the behavior of that function near a particular input which may or may not be in the domain of that function. Consider a function f of a single variable x. Let x approach a value c which may or may not be in the domain of f. Then, as x approaches to c, f of x will approach the unique real value called the limit L. In symbols, it is written like this. This is read as the limit of f of x as x approaches c is L. What is the limit as x approaches 5 of x squared plus 2x minus 4? So notice that we don't have a fraction and we're not gonna get a 0 and in the denominator. So for a question like this, you can use direct substitution. So all you gotta do is plug in 5. So it's going to be 5 squared plus 2 times 5 minus 4. 5 squared is equals to 25 and 2 times 5 equals 10, copy minus 4. 25 plus 10 is 35, copy minus 4, and then 35 minus 4 is 31. So the limits is going to be 31. Another example. So, in this example, we're doing again a direct substitution. So, the expression is asking the limit as x approaches to 2, x squared minus 2x minus 3. So, when you're dealing with a limit, all you have to do is plug in a value of a function. So it's going to be 2 squared minus 2 times 2 minus 3. So 2 times 2 equals 4. 2 times 2 equals 4 minus 3. So 4 minus 4 minus 3 is negative 3. So that is the limits as x approaches to 2 for that function. Let's say if we want to find the limit as x approaches to of the function x squared minus 4 divided by x minus 2. So how can we do so? Well, one way is to use direct substitution. If we plug in 2, notice what will happen. So 2 squared minus 4 is 0. 2 minus 2 is 0. So 0 over 0 is undefined, which we don't know what value that represents. How sometimes you could find the limit by plugging a value that's close to 2. And that's you want to do, you want to plug in a number that's close to 2 but not exactly 2. So for example, let's call this f of x. So let's calculate f of 2.1 and let's see what's going to happen. 2.1 squared minus 4 is 0.41. 2.1 minus 2 is 0.1. So this is going to be 4.1. Now what if we pick a value that's even closer to 2? For example, let's try 2.01. So if you type like this in the way you see it in your calculator, you may have to put this in parentheses. So you should get 4.01. So notice what's happening. As we get closer and closer to 2, the limit approaches 4. So we could therefore say that the limit as x approaches 2 of this function is equal to 4. And this technique works for any limits as long as you plug in a number that is very close whatever this number is, but not exactly that number. If the limit exists, it's going to converge to a certain value. Now sometimes you have to use other techniques to get the answer. In this particular example, we could factor x squared minus 4. You can write it as limit x approaches 2 of x plus 2 times x minus 2 over x minus 2. Now, notice that we can cancel x minus 2. So when the term is gone, you can now use direct substitution because the x minus 2 factor was giving us a 0 in the denominator which we don't want. So now, all we need to do is find the limit as x approaches 2 of x plus 2. So now, we can replace x with 2 and 2 plus 2 is 4. And so, that is the limit it approaches a value of 4. Limit as x approaches 9 of square root x minus 3 over x minus 9. So what should we do if we're dealing with the square roots? What I recommend is to multiply the top and the bottom by the conjugate of the expression that has the square root, so the conjugate of square root x minus 3 is the square root x plus 3. So the square root of x times the square root of x is the square root of x squared, which is simply x. And then we have the square root of x times 3. So that's going to be plus 3 square root x, and then these two will form negative 3 square root x. And finally, we have negative 3 times positive 3, which is negative 9. Now, on the bottom, I'm not gonna FOIL the two expressions. I'm gonna leave it the way it is, because my goal is to get rid of the x minus 9. I want to cancel it. So now, negative 3 and positive 3 add up to 0. So now, what we have left over is the limit as x approaches 9 of x minus 9 divided by x minus 9 times square root x plus 3. So now, at this point, notice that we can cancel x negative 9. So we have left over is the limit as x approaches 9 of 1 over square root x plus 3. So now, what we can do is replace x with 9. So I'm going to continue up here. So it's going to be 1 square root 9 plus 3. And square root of 9 is 3. And 3 plus 3 is 6. So the final answer is 1 over 6. So, what is the limits as x approaches 3 of 1 over x minus 1 over 3 divided by x minus 3? So, in this example, we have a complex fraction. If you get a complex fraction, what I recommend is to multiply the top and the bottom by the common denominator of those two fractions, that is by x and by 3. So I'm going to multiply the top and the bottom by 3x. So if we multiply 3x by 1 over x, the x variables will cancel, and so what we're going to have left over is simply 3. And if we multiply 3x by 1 over 3, the 3's will be cancelled, leaving behind x, but there is a negative sign in the front of it. Now, for the terms on the bottom, I'm going to leave it in its factored form. So, notice that 3 minus x and x minus 3 are very similar. If you see a situation like this, factor out a negative 1. If we take out a negative 1, the negative x will change to positive x, and positive 3 will change negative 3. So notice that we could cancel the x minus 3 factor at this point. And so what we have left over is the limit as x approaches 3 of negative 1 over 3. So how we can use direct substitution? So let's replace x with 3. So it's going to be 3 times 3, which is 9. So final answer is negative 1 divided by 9. Let's talk about limits at infinity. What is the limit as x approaches to infinity of 1 over x? Well, let's start plugging in large numbers. Whenever the denominator is large, you're going to get a small value. If the denominator has a small value, you will get a large value. So for example, 1 divided by 10 is 0.1, and 1 divided by 100 is 0.01, and 1 divided by 1,000 is 0.001. Therefore, we could say that 1 over infinity, which is a very large number, is going to be about 0. So the limit as x approaches to infinity of 1 over x is therefore equal to 0. Now, What about the limit as x approaches to negative infinity of 1 over x? 1 divided by negative infinity will still be 0. If you divide 1 by negative 10, this would be negative 0.1. If you divide 1 by negative 100, you will get a negative 0.01. If you divide 1 by negative 1000, you will get negative 0.001. It's still approaching 0 just from the left side. So this is 0 from the right side. This is equal to 0 from the left side, which you could say it's equal to 0. Now, what about this one? What is the limit as x approaches to of x squared plus 3x minus 10 divided by x minus 2? So, we can plug in a 2. If we do, we're gonna get a 0 in the denominator. And it's going to be undefined. So we got to factor. How can we factor this trinomial? To do so, find two numbers that multiply to 10 but add up to 3. Two numbers that multiply to 10 are 5 and 2. Now, we can make it negative 5 and positive 2 or positive 5 and negative 2. Now, we want to make it positive 5 and negative 2 because those two numbers add up to positive 3. So therefore, x squared plus 3x minus 10 can be factored as x plus 5 times x minus 2. And we need to rewrite the limit expression. So as you can see that we can cancel the factor x minus 2. And so we're left with the limit as x approaches to 2 of x plus 5. So now we can use direct substitution. So we're not going to get a 0 in the denominator anymore. So it's going to be 2 plus 5, which is 7. So that's the limit as x approaches to 2 of x squared plus 3x minus 10 divided by x minus 2.